Hi learners, welcome to IoT design and applications. So today's session will be on Industry 4.0. So with that, which leads to Industrial IoT. We call Industrial IoT is IIoT. So this is what we call. So why this is included in our curriculum is so most of the industries in the forthcoming years, so they will be involving the industrial IoT process of resource planning, production planning, manufacturing process, automotive. You take any industrial sector, so they will be moving towards industry 4.0 in the next forthcoming years. So that's why this topic is included. And the overview is, so we will be seeing what is industry 4.0, what is the definition of industry 4.0, and what are the components and characteristics of industry 4.0. Okay, so along with this, this is a week 2 topic. So week 2 topics, the theory part is very small, and whereas the design part is will be taking more design and the Contiki operating system. So after this session over, so you just please follow through the Contiki operating system and the IoT design applications. So what leads to industry 4.0? So as you see that in the industry 1.0 is the 17th century, where the mainly based on this water based industries, steam power and mechanization. So everything becomes mechanical, right from the human being, their human being, horses, they were being used for all these equipments. But after that, it was the first in 17th century, it was mechanized completely based on these things. So that's we call industry 1.0. So in industry 2.0, in the which came after 100 years from the industry 1.0, so it was mainly dealing with mass production, assembly line and electrical energy. So mainly electrical energy and assembly lines were introduced in the 2.0, and that was continued for the next almost 2 centuries. So in industry 3.0, so what we are experiencing now, or 10 years back what we were experiencing is automation, computerized, and most of the electronic devices and components. So these were being used in the industry 3.0 in the 20th century. But today's sector, so what it does is cyber physical systems. So everything with the help of automatic control systems, then IoT. So as we are going to see, then augmented reality. So any application that we are going to design, so first before we go in reality, so we just test it for how it looks like in the real platform. So for that we use augmented reality, simply we call AR, VR, virtual reality, augmented reality. So then we analyze with a huge number of data, big data, then simulation. So most of these applications before they've been deployed, so it will be simulated, and autonomous robots play a major role in so many industries, and most of these applications are cloud based. So this is how the way the industry 4.0 has been transitioned from industry 1.0 for the past 4 centuries. So we will be seeing what are the different components involved in it. So definition as per the various remarks by the various scientists across the globe, the definition says that industry 4.0 enables manufacturing sector to become digitalized with built-in sensing devices virtually in all manufacturing components, products and equipments. So irrespective of products or equipments anywhere, so it was using the sensing components. So that's where we call this industry 4.0 takes a major role. So that's why this IoT and sensors came into existence. Then somebody else is saying that industry 4.0 is surrounded by a huge network of advanced technologies across the value chain: service, automation, AI, robotics, IoT and additive manufacturing are bringing in a brand new era of manufacturing process. So a new word called as additive manufacturing, as we see that there are 3D printers and other stuff. So they have been brought into this industry 4.0 along with the existing technologies like AI, robotics and IoT. So this also is one of the definition of industry 4.0. And finally, the modern and the more sophisticated machines and tools with advanced software and networked sensors. So that's what we call networked sensor, means the sensor that are in network, so that can able to do so many preventive actions. It can actuate, it can be a sense, and so what are the things we can use is plan, predict, adjust and control the societal outcome and business models to create another phase of value chain organization, and it can be managed through the whole cycle of the product. So whole cycle of the product means, so the entire right from the planning to the product strategy execution, so the complete thing will be using industry 4.0. So to begin with, so there are so many automotive sectors like so many car manufacturers, even in Chennai or in India. So Hyundai, Maruti. So most of this manufacturing also it has been adopting this industry 4.0 standards. So meaning that the production of cars starting from designing the car to the final product, it encounters so many industrial 4.0 standards, and finally the product is outcome. So that's how the growth of industry 4.0 has been taken into play. So now the components of industry 4.0. So there are, what are the different components involved before we go for industrial IoT is, first thing is horizontal integration, vertical integration and engineering integration, or we called as end-to-end integration. So what are the different integration thing is, so in the horizontal we can see material control, financial control and knowledge control. So horizontal is in the sense that, so before we design a particular product, so where the material has to be procured and what kind of financial commitments are involved, and how, what are the knowledge means who is going to develop what, and that's how this first initial level planning will be happening. So that is a horizontal integration. In the verticals, what we see is physical subsystems, informational subsystems, production management, sensor and actuator planning. So all these things happens at the vertical integration. Apart from that, hierarchical subsystems of production line. So in the production line, so what are the different products or subsystems are involved, so how to design those subsystems. So all these things will be planned in the verticals. Then we have enterprise resource planning, how the resource will be managed across the entire product cycle. So that's ERP. Then finally we have end-to-end integration, or we call as engineering integration. So we can see the customer requirement, recycling, product development, production engineering, etc. So these things happens at the engineering integration. So that means that what was the requirement of the customer, so how, what the customer really wants. You take, for example, you take a car, so how the, what is the experience of using a car, so how you take a customer survey, and what are the recycled products used for production of the door of the car or the window shields, or any even the engine components, engine itself is running from a recycled product. So how it can be happening, then how the product is being developed, what are the production engineering components. So everything matters a lot before it is coming to designing of a particular product. So that's how this industry 4.0 evolves. So what are the different components of industry 4.0? So maybe this topic might be redundant, but what are the different topics for industrial IoT is, so we can see that IoT, Internet of Services, augmented reality, cyber physical systems, additive manufacturing, IoT, cloud computing, autonomous robots, big data and simulation. So all these components are part of this industry 4.0. So either one way or other, so most of the companies that are adopting their 4.0 standards, they will be encountering all these applications. So you just think of a particular application, one who is producing the nuts and bolts, so even they also encounter all these applications. So in a particular industrial setup as on today in the 21st century, so we cannot deny a computer engineer to be there in a particular pure mechanical company. We cannot deny that. So because of this cloud computing, because of this IoT, because of augmented reality and because of big data, so everywhere we involve computer science. And if you see that IoT and the services and additive manufacturing and here cyber physical systems, electronics and electricals are involved. So having said that, so all the parts of the engineering will be assisting or available in a industrial IoT setup. So that's what here this components describes that these are the things are mandatory for industry 4.0. So now you can see a typical requirement designed by a company. So you can see what are the different operations takes place. So here we have machine learning. So machine learning and analytics, they are part of big data. So big data, and here we have a software API. So API means application programming interface. So application programming interface. So that's what API. So API is a set of classes, functions that are developed for running some software. So we have a compute and we have a storage. So we have a processing power and we have a storage, and here there is a platform. So this entire thing is deployed on a cloud. So this entire thing deployed on a cloud, and here we have products coming out, raw materials going in, and here the physical process, the actual engineering happens here in this. Here we have sensors and here we have motors and actuators. So the physical process involves what are the different sensors available for protection of this process, and based on some of the sensing equipment, so there will be some actuator. That means that if a light is there, if sound is there, so actuate something. So accordingly the actuators are employed with the motor so that some kind of actions will be taking place. So all this data is being sent wirelessly to the connectivity module. So in the connectivity module, here again we have a list of software APIs. So list of software. So who manages? Data scientists are managing, logistics is managing, physical plant management and physical plant operators. So even the operator also sitting at a remote location, on monitoring the particular physical process with the help of the software API, then connectivity, then motors, actuators, and then physical. So this is how the way the industrial IoT paves a major uh, operations in the IoT industry 4.0. So most of the data which is stored from this here will be stored to the cloud. So whenever any data scientist need a data, they can directly access this from the cloud. So this is how the way the data access will be between the cloud and to and fro from the physical plant to the cloud is happening. Okay. So that's how, and even sometimes the end products also, even the end products also uses cloud in the recent days. So you can see that there is a car when it is driving, the car is driven on the road. So whenever it is the car has been driven, so automatically the data about the driving style and the speed of operation, everything will be stored to the cloud. So the car, everything will be stored to the cloud. So whenever the car is moving, so that means that whenever the car is went for the servicing or repairing, so automatically they can able to tap the data from the cloud and about the what kind of servicing will be possible for that particular car. So these things are happening in only because of this industry 4.0. So now what are the different components in the cyber in the industry 4.0 is, so we have cyber physical systems. So here it's a foundation of the creation for IoT. So before IoT starts, so we call something called a cyber physical system. So that is what the cyber physical system is, like software plus hardware plus control. So these are the three things for the cyber physical system. So the control will be the control and guidance part. So this will take care of the entire hardware software control. Each protection system of CPS we simply call as cyber physical system, has sensors installed in the entire physical aspects in order to connect the physical things with the virtual models. So we have virtual models which is directly connected to the physical things, so that whenever you do some any changes to the virtual model, they can able to make the changes in the physical model. So that's how the way the cyber physical system have a control. So one good a good example is we have a browser based system. So let's say in a browser based we have, let's say, an arrow in the left hand side and arrow in the right hand side, and here the up arrow and the down arrow here. So this is how the way in the browser it is displaying 4 arrow buttons, and in between there is a motor here. So let's say this is at location A. So location A, I will use LA. LB is a place where we have a motor. A motor is connected. Here there is a spindle. So accordingly the spindle here, this is a spindle. It's a kind of spindle, and there is a rod here. A small rod will be rotating in this direction. So this is how the way this motor is spun. Let's say this is a servo motor. That's a servo motor. So now for example, this is a browser. Let's say this is in Singapore and this is in India. So now what I do is, whenever I use the left arrow, whenever I press the left arrow in my browser, automatically the rod here will be simply turning around in the left hand side. So this will be doing like this. Whenever I do press right hand side, automatically it moves to the right. And whenever you do the up arrow, then the rod will be moving like this. Whenever I press down arrow, the rod will be moving like this. So in this way, I can able to remotely control a particular device or particular motor from a remote location within with a minimal response time. So minimal response time. So let's say in milliseconds. The response time in less than milliseconds. So this is how the way the cyber physical systems play a major role. So after the cyber physical system, that leads to the IoT applications based on the networking addressing. Okay. So what future this servo motor is having? This servo motor might be connected to Ethernet or a Wi-Fi. So it will be connected to Ethernet or a Wi-Fi for connectivity, so that this can establish a connectivity between the browser and a remote device. So that's how the way the remote diagnostics is happening in industry 4.0. So next thing is IoT. As we have seen enough of information about IoT, but here the IoT, the main here is monitor, optimize, control, automate. So these are the 4 jobs of IoT. So monitoring the environment, optimize the environment, control the environment, and completely automate the environment. So this is how the way the IoT play a major role. Next thing is Internet of Services. So what are the different services a particular sector can able to get from the internet? So Internet of Services acts as important components in the automotive industry. So mainly this automotive industry, they are in need of this Internet of Services. Activities are triggered through data transfers in the information technology to make daily mobility safer, easier and pleasant. So the mobility will be safer, easier and pleasant mobility we wanted to give in the automotive industry. The IOS acts as service vendors to provide services through the internet according to the types of the digitalization services. So what are the digitalization services available for a particular sector of industry? So accordingly those services will be available to those particular industry. So one good example is let's say you take a automotive industry wherein there is a production plant or the shop floor, we can call a shop floor. So in the shop floor there will be some let's say an engine is being designed and then manufactured over there. So that is one location. So for engine manufacturing alone there will be some different services are needed. On the other way around, in the different shop floor there will be protection of the doors of the car. So doors of the car need different kind of services. So all these services they are being powered using this IOS, Internet of Services. Accordingly, each and every shop floor will be eligible for a particular kind of services they are in need of. Okay, so that's how the way this IOS is planned. Next thing is big data analytics. As we seen that the huge number of data. So let's say you take the customer survey. Let's say you take Hyundai, or you can take a company called as BMW or Benz. So they have the global market. So every year they will be taking a survey from the customer survey from across the globe, and using that data they predict their business decision. They take business decision based on the customer or consumer behavior. So that's what this big data analytics is planned. So it is for predictive manufacturing. So that means that they can predict in what way we can improve the manufacturing. So accordingly they will predict based on the data available with them. So that's big data analytics play a major role. Next thing is augmented reality. So here this augmented reality is, it can predict with high accuracy and allows the frequency of maintenance to be kept at low numbers by utilizing predictive maintenance to prevent any unplanned reactive maintenance. So here it is augmented reality. So augmented reality means, so before we design actually a motor, so what we do is, so let's say you take a empty space here. So let's say I want to design a motor with two armature or anything. So before the motor is been or before the machine is been produced and manufactured, so I want to check how it works. So what I do is I will just design this motor and then fix it on the empty space, so that using any goggle or using any special glass or even in the browser, so we can able to see whether how the machine operates. So without really actually designing the machine, so by using simply software I can control the machine. I can press this button, I can press this, and I can check the operation of the machine. So based on everything is working fine, so then I can take it this into a real model. So that's how the way the AR play a major role. So another example is the augmented reality and the road conditions. So let's say I want to drive a car. So the car is driven in various road conditions. So one road condition will be, I just wanted to go on a tar road. I just wanted to go on a road with there are so many ups and downs. There is a road with the cement. So in all these road driving conditions, let me drive a car. So how the car behaves it. So I cannot really test a car before it is been developed. So before I develop a car, what I do is I just drive a car with the help of this augmented reality. So then I will get the performance of how really this car will drive itself. So accordingly I change the engine parameters, I change the air fuel mixture, I change the spark plug, I change everything, and accordingly I will drive the car. So it's kind of a simulator that before I go for a, let me go and simulate and find out what's happening, then I will go for a designing the complete product. So that's how augmented reality play a major role. Next thing is autonomous robots. So you might have seen in some of the movies that how the autonomous robots are helping, and even in some of the hotels in India. So the instead of the server in a hotel, one who come and serve you, the robots will be bringing the plates and everything, the prepared dishes, the robots will be bringing to the table. So that kind of autonomous robots are in industry 4.0. So in most of the industries, for fixing even a screw, nut or a bolt or anything to a particular engine or anything, so everything is been taken care by the robots. So what kind of pressure it has to give, so what is optimal pressure, so everything will be handled. So manual intervention is always, so let's say one good example is I have a car, again I take the example of a car. So the car I want to fix a tire, so there are 4 tires I want to fix it. So manually if I fix it, so all the 4 tires cannot be firmly fit as the same value, but using autonomous robots, all the 4 tires will be fixed exactly with the same pressure and everything. So in that case, these autonomous robots also play a major role. In most of the industries in the country, they are employing robots for designing so many things. So one good example is the once the door is designed for the car, so the door will be automatically placed using only by robots. So that means the robots will make the job easier and timeliness. So that means if a human being can fit all the 4 doors for a car, it takes 3 hours, means a robot can simply take just within 1 hour. So that means automatically 2 hours is been optimized over there. So that's how the way autonomous robots are the great demand in industry 4.0. And you can see in future robots will interact with each other, collaborate actively with humans under the guidance of the handlers. So that means the robots can able to talk to the other robots, and then they can able to talk to the handlers also. That means one who is taking care of them. So additive manufacturing, which it is 3D printer is one of the greatest invention of the era. So any kind of equipment or anything, we just need only a 3D printer to print it. Maybe the printing time will be very huge, but the printing errors or anything will be very minimal. So once you design the product and you can give it to the printer, it will print as per the specification. So even the raw materials also can be fed into it. So if you want a plastic thing, if you want a fiber equipment, or if you want anything, so we can give it. So that is what one of the best example is 3D printer in the additive manufacturing. So cloud computing. So as every one of us know, that cloud computing is it's a pay as you go model. So we call it as pay as you go. So that means you need not invest upfront a huge amount of money to store the data, to store the processing power, or to have memory, everything. So get a cloud space of minimal price. So once a pay as you go means, so once you are enlarging your industry, so according to the data requirement, you can pay as you go model. That means that, so pay for the number of users employed in your organization. If there are only 10 users, you pay for 10 users. If you cross 10,000 users, accordingly your profit also will be very huge, your margin is also very huge. In that case, pay for 1,000 users. That's how the way the cloud systems are being there. So a small amount of money allows enterprises or individuals to access these resources in the cloud servers. So most of the resources you need not to have a complete data center. So 10 years back, what happens is most of the manufacturing industries, they have a separate computer server setup placed in their organization. They will be deploying 2 or 3 people over there to monitor the entire data center. But now there is no need of a data center, because the entire data center could be in the cloud. So we can pay only for the operational expenditure, no need of capital expenditure. So cloud, the advantage of cloud is only OpEx is needed, CapEx is not at all needed. So that is the main advantage of cloud computing. Then finally simulation. So in simulation here is, as I already told you in augmented reality, it's kind of a simulation. Simulation modeling is a way of running a real or virtual process or a system to find out or guess the output of a model system or a process. So before I want to know what really happens, what is the output of my particular process, before I really develop a process, I will just simulate this network to get the complete model system, and I will check what are the outputs. I give the input and check whether the required desired output is coming or not. If it is not coming, I alter the system according to the performance. So accordingly, I will just develop this product. Simulations are done by using real-time data to represent the real world in a simulation model, which include humans, products, and machines. So it's a real. Most of the simulations runs on a real world data. So based on the real world data, if these are the inputs, these are the required desired outputs I should get. If I am not getting it, so there is something wrong in the process, so I will change the process. So accordingly, once I refine everything is fine, then finally the simulation I can go to the emulation, next I go to the final product. So that's how the way this simulation will be happening. So these are the different components for industry 4.0. So what are the different questions for the learners? So just have these questions in your mind. Machines are speaking to you, are you listening? So the machines what you are using, they are speaking to you, are you listening? So that is one, you just think of any machine or any process that is talking to you. So for example, if you are purchasing a car in 2020 or 2021, the car will be talking to you, not orally. The car will inform you as and when what something is happening to the car through this dashboard, or the car will give an alert. So these kind of things, your machines will be talking to you, trying to talk to you. So only thing is we have to listen to the car or listen to the machines. Can you think of any smart industrial business proposal that uses all the above components of industry 4.0? So think of any industry that they use all these components what I was seeing: simulation, autonomous robots, augmented reality, IoT, Internet of Services. cyber physical systems. Can you think of any business proposal that you would like to give that uses all the components that leads to industry 4.0? So having said these things, so we are in the module number week number 2. The module number 2 or 3 is completely on machine to machine IoT. So now we'll see more details on how to design an IoT application using a required operating system and a simulator. So that's what we are going to see. So thank you for listening. Thank you, learners.